Okay, I guess everyone has the syllabus, and let's start with the first lecture today. Okay, good afternoon, everyone. So, welcome to the ECES 3.1, the Transfer Methods and Filtering 1. So, my name is Li. So, I will be the instructor for this course. I hope you will enjoy this course with me. And so let's first talk about the syllabus a little bit before we start the first lecture. So yeah, as you can see here, so we have two lectures every week. So Monday and Wednesday morning, from 8 to 9:20 in this room, level 134. And also we have a recitation session on Friday from 9 to 10:50 a.m. still in this room. And so I will discuss each lecture or recitation includes what part. So you can contact me at the email address shown here on the syllabus, or you can text me or call me if you want. And my office is in Boson building, just next door, 604A. So there's 604, but there's another door for 604 actually. So currently it's a separate room now. So it's 604A, just next door to the women's restroom. And I have office hours after each lecture. So you're welcome to use these office hours to talk with me or have some questions we can discuss. So basically this course will cover some very interesting or important concepts in signals and systems if you're in electrical engineering. So you must know some basic knowledge on the signals and the systems. So we will cover some modeling and analysis on the signals and the systems. So we discuss the problems of physical systems and their mathematical solutions of models, and we will cover continuous time signals, discrete time signals and systems, and linear time invariant systems, convolutions, and then the most important thing is the Fourier series and the Fourier transforms. And the textbook we use is the Signal and Systems, the second edition by Alan Oppenheim and Wilski and Newell. So which is, as I know, I think it's the best textbook I've ever seen for the signals and systems. So this is a required textbook, so you can order a copy from the bookstore, or you can buy whatever source you want, either Amazon or some used book is okay. Just to make sure it's second edition. And for this course, we will use the Drexel's Blackboard learning system to manage the homework assignments, solutions, and exams, and grades will also be posted there. So you must check regularly for these updates. And also make sure you have your Drexel email account properly set up so that when I send announcements, you will receive properly. So as I said, we have lectures and recitations. So each lecture, we will basically cover the concepts and the theories. And since every lecture we have limited time, so we will not cover so many we will not cover so many examples or problems in lectures. That's why we have a recitation session. That's mainly for the problem practice. Because for this course, if you want to get a good grade or succeed for this course, you must practice and practice a lot and work on the homeworks, problems, and the quizzes. So every recitation we will have a small quiz unless there is a midterm exam. And so you are required to attend the recitation session, because otherwise you will miss the quizzes and you miss a lot of chances for reviews of the lectures. So another important question is the grading policy. I think this is the most important that you are interested in. So we have a non-homework assignments, and they will be the two lowest one will be dropped. So there will be 20 points associated with homeworks and 20 points associated with the 7 quizzes. And also the two lowest one for the quizzes will be dropped. And we will have 2 midterm exams, 30 points for them and 15 for each. And finally, we have the comprehensive final exam. So we have 30 points for that. And I will notice you when the date and location is scheduled. So an all homework will be assigned on Wednesday and due 1 week later at the beginning of the class. So discussions on homeworks are allowed, but you are not allowed to copy solutions each other, because that will be viewed as cheating, and which will cause you a 0 for the assignment or even fail this course. And since I will drop 2 lowest ones, so no list submissions will be accepted. Just to let you know that. And also for similar for the quizzes. So if you miss the quiz, I will just simply give you a 0. That will be counted as a dropped 2. And yeah, all the quizzes or midterms exams are on Friday, recitation sessions. So just to make sure you can come. And also, since the necessary equations will be given, so I will attach a equation sheet to each quiz or exam. So there will be no book notes allowed in all the quizzes or exams. And you are welcome to use some basic calculators. I don't think you need that. And no other electronic devices are allowed in the quizzes or exams. And then your final last grade will be given following by this small table. And probably I will scale up, but not scale down, so don't be scared. And then the course schedule. So basically, I will follow this schedule to cover the material in the book. So we will basically cover up to chapter 5, or at most, if we have time, we will cover chapter 7, section maybe 1 or 2. So I will also follow the order of the book to cover these materials, as you can see here. So, and then the general class policy is that no cell phones use is allowed, and except for emergency, of course. And the computers or electronic devices must be limited to note-taking or in-class completion exercises. And so since it's very early in the morning on Monday and Wednesday, so I think I need to have some attendance policy. So absence must be excusable, resulting from a circumstance beyond your control. And you must provide a written statement regarding the reason for absence. So otherwise, I will take off some points on your final grade. And in principle, no makeup exams will be given if you miss one. So just schedule as early as possible. Since I've already given the midterm dates, so just schedule avoid the conflicts of the exams. And if you do have some reasonable excuse, as stated above, so out of your control, please see me if you missed one exam. And some other academic policies, you're welcome to look at that, especially the dishonesty, so no cheating is allowed. And if you have disability, so you can find some resources, and also the cost drop policy. Okay. So any questions on the syllabus? All right. So yeah, now let's start with the first lecture. So as I said before, so this course will basically covers some modeling and analysis for the signals and systems. So in our daily life, so we know we talk about the signals and systems in many situations, right? Like when we speak, we know this can be called a signal, speech signal. And so some other signal examples or system examples, like the voltage, since we are electrical engineers, so the voltage across a resistor, so we can view it as a signal. And you know, if you have input, you have input to input voltage as a signal, and after some calculation, you can calculate out the current flows through this resistor. So this is a simple signal and system, actually. So you have voltage, signal, input to a system, and then you have calculated out the current. And another typical signal and system example could be, when we make some phone calls, so your speech signal goes into the phone, your cell phone, and then after some processing, and then the some electronic wave transmitted out to the air. And also, like the light intensity on your smartphone screen with respect to the pixel locations. So which looks like the image, also it's like an image, and you have different brightness on different pixels. This is also a typical signal. And also even the number of money, the number of dollars in your account with respect to the time, you can view that as a signal as well. So like in the textbook, it also have the Dow Jones stocks. So with respect to time, so that can be also viewed as a signal. So from this example, we can see a signal. So we can see what is a signal. Actually, a signal is a function of an independent variable that carries some information. So like the examples we showed. So the speech that carries some information with respect to the time. So like the speech we know is acoustic pressure actually. And it usually looks like this. And this is time, so this is the pressure level. And so since it's a function of independent variables, so it could be one dimension or multiple dimensions. Like the image, a 2D image, so it has 2 dimensions, and then you have a brightness as the value. So which means this is a 2D signal. But in this class, so we will primarily deal with signals that are a function of only one independent variable. And for simplicity, we generally use time as the independent variable. But on some occasions, we will use others as well. But most of the cases, the problem we discussed will use time. And we have 2 basic types of signals. Which is the continuous time and discrete time. Continuous time means so your signal is a function of the continuous time, and the discrete time signal means your signal is a function of the discrete time. For continuous time, it's a function of this. It's continuous. And we will talk about the relationship between the two. How can we get a discrete time from continuous time data? So usually, maybe some of you may already know that we can do this by sampling the continuous time. So for continuous time, so how can we represent this signal? So we usually use x of t, so is a function of t, and we use the parentheses for this continuous time, and we use square brackets for the discrete time signal. And I will strictly follow the notations in this book. And I also require you to follow the notations in this book as well. So just to make sure we cannot confuse each other. And so since this is discrete time, so n must be integers. So we don't have a definition of like x half. This is not defined, so this n must be integers. So yeah. Okay, now we have these 2 types of signals. And next I will introduce the notion of signal energy and power. Because for many physical systems we are considering like the voltage and the current. So maybe we are interested in the energy or power contained in this signal. So we define the energy of a signal xt for continuous time first, and over t1 to t2 interval is the integral from t1 to t2, the amplitude of this signal square. So this is called the energy of this signal from T1 to T2. And similarly, for discrete time signal, since we have Xn here, and N1 and N2 will be the sum of the amplitude of xn squared from N1 to N2. And we know that power, what is power? So usually power is defined as the energy divided by time, right? Energy divided by time. Then we can follow this definition and we can define the power of xt over t1 to t2 as the power will be like t2 minus t1 and then integration from t1 to t2 xt squared t. And for discrete term, it will be from N1 to N2. How many points there? So it will be N2 minus N1 plus 1. And sum of them is coming. So the power is like average energy over this time period.